Hey everybody, quick snapshot video on revenue diagrams. We're going to focus on total revenue, average revenue and marginal revenue and try to form links between them. As you all know, the demand curve is otherwise known as the average revenue curve. Total revenue is the price times quantity sold, and therefore it tells us the amount of revenue generated by selling units at a certain price. The diagram at the bottom is the total revenue curve, which I've just drawn, and that's a curve that goes up and then comes down again. Now what you notice is at the unitary point of the diagram of the demand curve, which is in the middle, you notice that when you draw the equilibrium down, it touches the peak of the total revenue curve. So this suggests that when the demand curve is at 1 or is unitary, the total revenue curve is at its maximum. It's the maximum amount of revenue that you can generate. So this is interesting. Let's look at what happens before you get to Q and after you get to Q, because we want to understand why at unitary point revenue is maximized. Well, there's a reason why. The demand curve shows a relationship between price and quantity. Therefore, we've got to think about what happens when the price falls at the top half of the graph. Now, the top half of the graph I've just highlighted, we notice that the diagram, the demand curve, is elastic. Therefore, if we decrease prices, the revenue gained from more units sold will outweigh the revenue lost from the decrease in price. And that's what we mean by the quantity effect outweighs the price effect in the elastic region. This also will translate into the fact that it's generally a good idea for businesses, if they have elastic demand curves, to reduce the price. And if they do that, which is what's happening in the diagram above, you notice that the total revenue is going up all the way until the maximum where you get to unitary. Now the other side of the graph, of the demand curve rather, where you have inelastic features, here the price effect will outweigh the quantity effect. Meaning, if we increase the prices, the revenue gained from the higher price will outweigh the revenue lost from less units sold. This is why you notice that in the inelastic region of the graph, you notice that total revenue is starting to fall. Okay, so beyond unitary, where the demand curve is inelastic, total revenue is starting to fall. Finally, guys, we want to link marginal revenue to the average revenue and total revenue curve. And as you know, marginal revenue is drawn twice as steep as average revenue. And therefore, if we draw the marginal revenue curve in, we realize that it crosses the x-axis. Okay, and where it crosses the x-axis, where MR, where marginal revenue equals 0, you again notice that the total revenue is at its maximum point and the average revenue is at a point of unitary elasticity. And that's your link between average revenue, marginal revenue, and total revenue. Average revenue, when it's unitary, the marginal revenue is 0. And when the marginal revenue is 0, the total revenue is at a maximum. And again, either side of the marginal revenue being 0, you can also work out things related to total revenue. For example, if we look at marginal revenue, when marginal revenue is positive, okay, meaning that it's above the x-axis, so the position from here to here, you notice total revenue is increasing again all that time. So that's another rule. When marginal revenue is positive, total revenue is increasing. However, when marginal revenue is negative, so the region between here and here, total revenue is falling. And these are all the simple rules that you will need to learn in order to link average revenue, marginal revenue, and total revenue. Finally, remember from a previous video that revenue maximization occurs where MR equals 0. And that's exactly why it's called revenue maximization, because when MR is 0, total revenue is maximized. I hope that helps.